Welcome to clickmybazaar.com. Let me discuss the project about a fast and reposite level set method for image segmentation using fuzzy clustering and Lattice Boltzmann method. In this paper, we propose the Lattice Boltzmann method is used to solve the LSE. The proposed method is based on the approach of the LBM and the probability density equation solver defined in the proposed method using a modified fuzzy clustering method. Objective function: we design a new fuzzy external force. The method is fast, reposite against noise, and efficient whatever the position or the shape of the initial contour, and can detect efficiency objects with or without edges. It has first the advantages of the FCM, which gives it the lattice to stop the evolving curve according to the membership degree of the current pixel. Second, the advantages of this LSM, which allow it to handle complex shapes, topological changes, and different constraints on the contour smoothness, speed, size, and shape, which are easily specified. And third, the advantages of the LBM, which make it very suitable for parallel programming due to its local and explicit nature. The rest of this paper is organized as follows. This LBM models is presented. We explain the formulation of the proposed method. Then this method is very useful to generate at the 8 links with its neighbors and 1 link for the cell itself. LBM lattice structures, it's the partial distribution that moves along this link for this position of the cell and it's the time. The LBM evaluation is very useful to generate at the fast reposite image segmentation process. It's the block diagram of our project. First we will load medical and real-time images. The next one is pre-processing. Then Gaussian filter will be applied for input medical and real-time images. The next one is segmentation results of CV method. CV is chain wish method. Then chain wish method is very useful to remark the proposed method can give better results than the CV method and can deduct all the contours whatever the position of initial contour, while in the CV method the contour can be dropped in a local minimum. Furthermore, the proposed method is more than 100 times faster than the CV method and can be faster when implemented on graphics processing unit due to the local and explicit nature of the LBM solver. Then the next one is segmentation results of cube method. Then this method is the detect steps, corners, and has all the inconvenience of k-means algorithm. The result changes in the initial contour and one should run the algorithm several times in order to choose the best results. Thus this method cannot be used in automatic systems, and even if it paused when running it one time, the segmentation will take much time since the one should run segmentation will take off this method in several times. Then this CB-FitQ's method is whatever the shape and the position of the initial contour. We can also remark that the result of CB-FitQ method changes with the initial contour. Then the next one is segmentation results of proposed method in LBM Lattice Boltzmann method. This method has attracted much attention as a fast alternative approach for solving partial differential equations. We first designed an energy functional based on fuzzy C-means objective function which incorporates this bias field that accounts for the intensity and homogeneity of the real world images. Using the gradient designed method, we obtained the corresponding level set equation from which we deduce a fuzzy external force for the LBM solver based on the model by Zyugu. The method is fast, reposite against noise, independent to the position of the initial contour, effective in the presence of intensity in homogeneity, highly parallelizable, and can deduct objects with or without edges. Then the medical and real world images demonstrate the performance of the proposed method in terms of speed and efficiency. The next one is analysis. Then the three methods is analyzed to using that these order to objectively evaluate the proposed method. We can use the three well-known matrices of the used to do this analysis process. Then the three method is compared to at the we can also remark that these several times of this process. Then the K-means algorithm segmentation results obtained on a real-world image with different initial contours. All the CPU times are displayed in terms of quality and accuracy. It can be seen that the proposed method gives better results than the method whatever the shape and the position of the initial contour. Finally, it will analyze the process. Now let's see about the execution part. I am having main m.m file. Then select the file, right click, then run file. Here we have to select the input image. First of all, this one is original image and next one is noise removal. Then Gaussian filter will be applied for original input images. Then next one is this one is input image. Then initial contour for this method is CV method for sine inverse method. Then the 10,000 iterations are processed to the then pre-segmentation process. Then this method is CV method is very useful to generated at the each and every. These methods are remarked to the proposed method can give better results than the CV method and can detect all contours whatever the position of initial contour, while in the CV method the contour can be trapped in local minimum process. Then the CV method and can faster when implemented on graphics processing unit due to the local and explicit nature of the method. Then the next one is this one is initial contour of QBFITQ method. Then cannot deduct at the tips corners and cause all inconvenience of this one results for K-means results. Then this algorithm, the result changes with the initial contour and one should run the algorithm several times in order to choose the best result. Thus this method cannot be used in automatic systems, and even if it fast when running it one time, the segmentation will take much time since one should run the method several times. Then next one is this one is initial contour for LBBMM method, Lattice Boltzmann method. Then the proposed method has attracted which much attention as a fast alternative approach for solving partial differential equations for these results of LBM method. LBM method is the very useful to this part of the wide family of active contour method. The key idea that starter the level set whenever is the approach a time independent equation for a moving surface. Thus the Boltzmann method has been used to alternative approach for solving the process. Then these three advantages for this LBM method is used to solve the LSE level set equation method. The proposed method is based on the approach of the LBM. Then the probability density equation solver defined in the proposed using a modified fuzzy clustering method. Objective function, we design a new fuzzy external force. The method is fast, reposite against noise, and efficient whatever the position or the shape of the initial contour, and can detect effectively objects with or without edges. It has first advantages of this FCM, which gives it is a lattice to stop the evolving curve according to the membership degree of the current pixel. Second advantage is LSM, which allows it to handle complex shapes, topological changes. Then the third advantages of the LBM, which make it very suitable for parallel programming due to its local and explicit nature of the process. Then the Finally, the conclusions of the process is we have presented a level set image segmentation method based on the idea of stopping the evolving contour according to the degree of membership of the active pixel to the inside or outside of this evolving contour. It is done with the help of the FCM Marshall matrix. The LS is solved by using the powerful, simple and highly parallelizable LBM, which allows the method to be a good candidate for GPU implementation. The method gives promising results. These results are medical and real-world images have demonstrate the good performance of the proposed method in terms of speed, effectiveness in the presence of intensity and homogeneity, accuracy, robustness against noise, the efficiency whatever the initial contour. Further works can implementation proposed method using the parallel devices such as the GPU is in order to fully take advantages of the LBM. The method will be faster and suitable for this image segmentation. The image segmentation can also enhance for the very useful to generated at the correct level set equation method for the image segmentation process. Thank you.